This video is also going to be on completing the square, but it is going to have a new twist. What we're going to look at is if we have a coefficient on our x squared or our y squared term, and what happens if I want to get rid of a coefficient on x squared but not on y squared. What we'll do is we will factor out a value from only some of the terms. So two examples. So on the first one, first thing I'm going to do is I'm going to rearrange so I have my x's and my y's together and bring the 24 to the other side, giving me 4x squared minus 24x plus y squared plus 4y equals negative 24. Okay, so now just as I pointed out a moment ago, notice that I can't have, and we've already seen this, I can't have a coefficient on my squared term, and I have one on my x but not my y. So if I were to divide everything by 4, that would give me a coefficient of 1/4 on y squared, so I don't want to do that. So what I can do is I can factor out of 4 out of my x terms only. So 4x squared minus 6x plus y squared plus 4y equals negative 24. Now I can go ahead and complete the square for my two different variables. So looking at my x variable, I'm going to go ahead and take that negative 6, divide by 2, and I'm going to square that result. Taking my 4 from my y term, dividing by 2, I get 2, and I square that result. So I'm going to add both a 9 here and a 4 here so that I will have those perfect squares, giving me 4 times x squared minus 6x plus 9 plus y squared plus 4y plus 4 equals 24. Here's what's tricky. I noticed that I know I only put a 9 here, but because of the 4 outside belongs to everything inside through multiplication, I actually added a 36. 4 times 9 is 36. So when I add the 4 over here, I also have to add not a 9, but a 36, and that's the most common error I see. So I'm going to go ahead and do that. I'm also going to factor this at the same time. I'm going to say that's x minus 3 squared plus y plus 2 squared equals, and again I'm going to add that 4 and that 36. Doing that gives me, oh, but I realized I lost my negative here, so that was negative 24, excuse me. That gives me, looking at my work, 16. So then I have 4 times x minus 3 squared plus y plus 2 squared equals 16. Now, I didn't put them on here, but if I were to look at my vocabulary, the standard form of ellipse tells me it should be equal to 1. So I'm going to go ahead and divide everything by 16. I can reduce here, giving me a final equation of x minus 3 squared over 4 plus y plus 2 squared over 16 equals 1. As I said a moment ago, there are only 2 examples here, so the next one, if you'd like to try it, go ahead and pause the video. Alright, looking at this, again I'm going to start by grouping my terms. So I'm going to go ahead and say x squared plus 4x plus 4y squared minus 40y, I'm going to bring that back over, equal 103. I'm going to go ahead and factor a 4 out of my y terms, giving me x squared plus 4x plus 4 y squared minus 10 equals a negative 103. And now I'll go ahead and complete the square. Linear term over 2, square the result. And I lost my y on my 10, I realize, so I'm going to try to squeak that in there. So then negative 10 over 2, taking and squaring, completing the square for both variables. And now I'm going to add those in, so I get x squared plus 4x plus 4 plus 4 times y squared minus 10y plus 25 equals a negative 103 plus 4, and again, because of the 4, it belongs to everything in here. 4 times 25 is 100, so I'm going to have to add 100 here as well. And now I can go ahead and complete that square. X plus 2 squared plus 4 times y minus 5 squared equals, adding those together, I get 4. Oh, actually that does not give me 4. I didn't realize on my sheet I had changed this 103 to 100 to make it work better. So this should have been a 100. So I'm just going to go ahead and change that all the way through because it just makes my work turn out a little bit nicer. And then I do get that 4, and then I can divide both sides by 4 to give me that ellipse that is equal to 1, giving me a final equation. And if I wanted to, I could put this over 1 just so it does get that look of an ellipse. And here is my equation for my ellipse. So just again a quick overview of completing the square, just looking at it at a little bit different angle of factoring out. Just don't forget, especially because we get good at completing the square and we start skipping steps, so don't forget that you're not adding a 25, you're adding a 4 times 25. Just like in the previous example, you weren't adding a 9, you were adding a 4 times 9.